Hello everyone, we are pleased to bring you together today for this 30-minute webinar dedicated to the new challenges of big data, including BI and analytics. Key questions we will discuss today are: first, how are data access projects currently managed? Second, we will look after the following question: how to solve the equation of performance and analytics regardless of the volumes and the sources. Then we will go for a live demo on billions of lines, how Looker associated with Indexima are able to unleash on-demand big data analytics. And finally, we will wrap up and share the best practices to keep in mind. To start this webinar, I'm pleased to introduce you to Nicolas, Korchia and Shohei Narron. Nicolas is the co-founder and COO at Indexima. He has more than 50 years of experience in the field of technology, big data, and business intelligence. Shohei is Technology Alliances Manager at Looker, and he has a strong expertise in data analytics projects from end users to technology perspectives. Guys, the floor is yours.
Fantastic. Thank you for that kind introduction, Letitia. So first, let's have a look at the different options that we have in our BI and big data projects and why performance remains so critical. So here's what we're talking about. We've got analytics on the right side here, reporting, dashboarding, analytics applications, which apply to your data on that left side. This data is potentially very large and obviously not humanly readable. It's just raw information coming in. Now the question is, how do you input that data and output great actionable insights out of whatever tool you're using? And today, it can take months to find out what kinds of information people actually want and create a way to access it, but with time-consuming reviews and feedback sessions between the different teams. Now, this affects a very important concept known as time to data. This is the time it takes to move from raw data on your left-hand side to actual analytics results and action on the right side. And today, the biggest problem for companies is this time to data, which is extremely important, but not well understood. And I'll explain why in the next few slides. Now, there are two main ways you could implement analytics projects here, and they both have their specific pros and cons that will impact their time to data. The first one over here that you see, let's call these legacy business intelligence projects. Now, these projects are based on a rigorous review process, right? The quite common principle of ETL, extract, transform, and load applies here. The data collected through all of these processes are aggregated, divided into data of smaller sizes. They're called cubes, data marts, or business views. And with this level of data preparation, you're keeping only relevant data that you like to look at or you think you want to look at, which means you're able to avoid being overwhelmed by the quantity as well as the diversity of existing data. It's usually provided by automated scripts, and they're developed by teams of data engineers. This project structure, for better or worse, allows analysts to have at their disposal a data of reasonable size for them to look at because they're targeted. You're not looking at the entire data set. And because you reduce the amount of data to look at, it's also very quick to be analyzed by BI tools, right? You click on something and you have your answer. On the other hand, these techniques require specific development processes and teams dedicated to their implementation, which means there will be a lot of back and forth between analysts, end users, and developers to figure out what exactly they want. Finally, this data preparation process reduces the flexibility in the analyses you conduct. The data that's been reduced have now lost value. You can't really look at more granular information, and it's going to be very difficult to cross-join these data across different sources. When you've made a sales-centric cube and also a user-centric cube, you can't really cross the information from either unless you start a new data project. And in large enterprises, piloting these types of projects will take a long time. Time to data is then counted usually in weeks or months and will dramatically impact the time of decision making. Now, in recent years, a second type of project has emerged, and we'll call these big data or Hadoop projects. These projects increase the amount of data stored while improving project management capabilities. Right? One of the objectives of these projects was to reduce the development work that was needed in the data processing and manipulation chain in order to democratize access to data to anybody in the organization. And a lot of advanced tools exist in the Hadoop ecosystem to implement this and maximize the capabilities of these systems that you're utilizing. And these projects, when they're actually implemented, give a lot of flexibility to analysts and business users, allowing to use all information available at a very granular level. You won't have to be constrained by cubes, right, that were created in the legacy BI projects. These projects are, in theory, totally scalable. The Hadoop ecosystem was born from this principle of wide data distribution, but these projects, unfortunately, tend to fail more often than not for more than 80% of companies because of two reasons. First of all, the difficulty of implementation has been severely underestimated. The expertise you need from data engineers and other engineers is broad and deep, which make them very rare and more expensive when you think about your human resources cost as well as time. And these projects require so much server or infrastructure alignment that it often becomes unreasonable to scale, right? I mean, who wants to really spend several millions of dollars to analyze a few terabytes of data, or not even analyzing it, but setting up that piece of infrastructure? So the cost of these projects at the end of the day becomes astronomical. And finally, for those who come from the world of so-called historical or legacy BI, the time of reactivity, or how much time it takes to get an application set up, quickly becomes, I would say, deceptive. Right? To gain flexibility, these systems no longer have to pre-compute cubes and smaller data marts, which sounds great. It certainly simplifies preparation, but when it is necessary to ensure timely query response times on, let's say, 20 billion rows of data, the full scan is very expensive when it comes to performance. We're now talking about a few hours or maybe even days to go from raw data to analyzable data. And going from weeks and hours sounds great, but the consequences on time to market are still dramatic. And in short, this notion of time to data has improved a lot, but not enough to keep pace with users' performance expectations. And when you think about it, time is money. So going back and forth between teams is very expensive. We often hear about weeks or more in implementing a new dashboard. And in addition, these multiple rounds of feedback sessions lead to a real dissatisfaction from the users who will finally leave the dashboard in question. And there's also time to market. We all need to make decisions based on data, timely decisions, not just any old decisions. If these analyses take time and lacks flexibility as well as agility, your time to market is impacted. So you have, poor or slow decision-making processes as well as very unhappy users. Fortunately, at this point in time, we do have better alternatives. So to solve the time to data equation, we need the instant response times we had with a data mart or cube, with cubes and other pre-computed models. We also want combined that with the flexibility and the analysis we gained through big data Hadoop systems. But we also want all of that with a simple implementation process as well as reduced infrastructure costs. And that's where Indexima and Looker come into play with a new way of doing things. So Indexima and Looker allow companies to hyper-optimize their databases without moving data, thanks to Looker's in-database architecture that executes queries on your customer's data rather customer's database instead of computing in memory. So Looker doesn't actually have a database. We just connect to about 50 different kinds of SQL databases like Google BigQuery, Snowflake, Amazon Redshift, MySQL, Postgres. We're not going to take that data away. And you can combine that with Indexima's unique indexing technology combined with machine learning. And what Looker does is it runs live reports and dashboards on big data as soon as it's available in your database with best-in-class speed, scale, as well as security. And with that, I'd like to turn over to Nicolas. Hi, Nicolas, can you hear me okay?
Sorry, I shut down my microphone. It's no better. So thanks a lot, Shohei. From theory, let's go on a live demo of this zero time to data with Looker and Indexima. This live demo will be made on an open source data. This open source data is about New York City yellow cabs data. And in this data, there is one line for each taxi ride in New York City. It means a lot. My data is on S3, Amazon S3. The data visualization tool we use for the demo is Looker, of course. And in my CSV files, there are a bit more than 20 billion rows, 20 billion of lines in CSV files. I choose not to transform my data, so there is no data prep. And finally, in order to make the position of taxi usable, I added 2 association tables to find the different areas of Manhattan from GPS coordinates. Because on each line of trip, there is 1x and 1y, I mean 2 GPS coordinates for the departure and 2 other coordinates for the arrival. This last point is important because it means that I make joins using the GPS coordinates as key. Those who speak SQL will understand. In a nutshell, we want to make live access on 20 billions of rows in a star schema with difficult joins. Do you want to check if this is sustainable? Yeah, sure. In order to hyper-accelerate our data stack to deliver lightning-fast data exploration from the whole organization, we placed Indexima in between S3 and Looker. Let's get out of the slide and open Looker and Indexima. In this demo, I will show you 2 different things. The first one is that one. It's a web view on top of Indexima. In this monitoring console, we will be able to follow the different actions and response time of the demo. I mean, the response time of SQL queries we all love so much. Second, let's open our favorite database tool, Looker. Here, Shohei, I already prepared a dashboard on these 20 billions of rows. Let's clear cache and refresh. Okay, you can see my dashboard. And let me explain this first view. On the top, you can see the evolution of fair amount, distribution of fair amount and trip duration by borough. In my data, there is GPS coordinate, and those GPS coordinates are associated to a row. And here you can see average trip time or average fair amount. At the bottom, we can compare fair amount, number of trips, and sum of tips by zip code, the 3 maps. Let's play with this data using boroughs, for example, Brooklyn and Manhattan, and click Run in order to filter. Have you seen that in the monitor view of Indexima, it has blinking in blue? Let's try again with one of the queens. Look behind, it's blinking. It means that we are live connected on Indexima, and each time I interact with my Looker dashboard, there is SQL queries sent to Indexima. Let's have a look at one of them. That one, for example. It is selecting zip code and sum of tips from my model. It's an inner join, and there is the where clause with Brooklyn, Manhattan, and Queens. This query took 11 milliseconds in order to render the data coming from 20 billions of rows. Shohei, have you ever seen that speed?
Yeah, I would say that's pretty amazing. And one thing to note there is if your queries are taking 1 minute or 60 seconds and it goes down to less than 1 second, you're already seeing a 98% decrease in, or rather increase in performance. So that's pretty amazing. We're not talking about slightly faster queries. We're talking about very fast, much faster queries here that we're optimizing through Indexima.
Thank you. And I can filter on anything. It will be always the same speed. Let's go a bit further. Shohei, I would like to play a bit more with my data. And I would like to build with you a new tile based on that.
Yeah, let's.
Average of tip amount, for example.
Yeah, I know that we have fair amount, so maybe what we can do is go into the develop section.
Yeah.
And go into the project that this dashboard is based on.
Yeah, this is here.
And by the way, for those of you who are on the line, this is what we call LookML. This is where you write and standardize, define different kinds of business logic so that you won't have to write SQL queries yourself. And right now we have a whole bunch of mins, maxes, and averages. So we have average total amount there. What we'll do is we'll just maybe copy and paste average total amount.
Okay, let's copy that.
And we'll just change that name to average tip amount. In the next line, it says type average. That just says that Looker will write an average function. And for SQL, it says total amount. We will change that to tip amount. So now Looker will write an average of that tip amount SQL query.
Okay.
We'll go ahead and save that. Now, the benefit of doing this is you can define a query or a snippet of a query once, or rather a metric once, and then reuse it across the organization without having to rely on someone else to write it for you.
Okay, that was really simple to do. Now I would like to add a new tile here. So maybe I should refresh in order to refresh my model. Is that it? Yeah.
And that's it, yep. We'll just edit that dashboard. We'll click on new tile.
And here we can see the average of tip amount over there. Okay. So for the 20 billions of lines, the average of tip amount is $1. Okay. What I would like to do is to see the distribution based on the location. So using the borough or the zip code. Here with the zip code, yeah, let's use the borough because it was like that for the other tiles. Yeah.
And that too, actually, Nicolas, you just clicked on the zip code and said, I actually don't want zip code. I want borough instead. And that's something that you just wouldn't be able to do if every query takes more than a minute.
Yeah, you're right. As we can see, it's still taking 8 milliseconds, 6 milliseconds, 11 milliseconds in order to answer to those questions. And here, if we look at the SQL part, we can see the queries generated by Looker and then sent to Indexima. So if I had the zip code, for example, here the borough is just near to the zip code that has been added just in a click. If I remove, the query is updated, removing the zip code.
Exactly, which guarantees consistency across your organization, so you won't get, incorrect or unreliable results.
So let's name it average of tips by row. And save. Here we are, and let's copy that, and let's move that here.
It's at the bottom. There we go.
Exactly. Oh, as I can see, it's not filtered the same. So I think I have to go to my filters in order to say to all the filters to take the borrow, whatever the filter I apply. And here, if I run, it should filter for Brooklyn and Manhattan, for example. Yeah, wonderful. Now, I would love to go a bit deeper. I know that there is this functionality in Looker that I love so much about digging inside the data, going to find the raw data. I mean, each lines. Can you help me to go deeper? I mean, for example, for one zip code.
Yeah, absolutely. We'll just go back into that LookML view. And what you're talking about is actually a real big differentiator for Looker. It is a drill path. So what we'll do here for average tip amount is we'll create a new line in that snippet. And we'll start typing drill fields. And as you type, you'll notice autocomplete. Yeah. And in there, we'll just want to list a few different fields that you would like to drill into when you click on that result set.
Okay, so let's take some real raw data. I mean, the drop of date time, for example, or we are dealing with tips. So maybe the payment type and the tips itself.
Great. Yeah, we'll save that. And just go back to the dashboard and refresh it, and you should be able to click on average tip amount and drill in.
Okay, so my filters are still there. And if I click there, it is going to dig inside the raw data, picking some lines inside the 20 billions. It's a bit longer, of course, because we are going to get the raw data. Here it's done. So it took something like a few seconds. Yeah, 13 seconds in order to find the top 500 results inside 20 billions of rows. It's huge. And this is exactly what I wanted to see. I mean, here the raw data, so one line for run ride with the payment type and the real tip. Thank you, Shohei. Let's go back to the slide. So here, what we've seen is Looker using Indexima to dig inside 20 billions of rows in CSV files on S3, computing agile KPIs at the row level live. Thanks a lot, Shohei. This is the real zero time to data and the low latency we want to deliver inside each BI tools. This is a way Looker and Indexima combine to unleash and demand big data analytics. We commit to instant response time with Indexima superfast MPP engine and Looker agile analysis platform. The solution is really easy to implement, whatever your environment, to gain insights from increasing data without any effort. Indexima makes databases faster than any other engine in the market, with queries response time below a second. Looker takes full advantage of this technology, allowing users to explore their own data ad hoc without waiting on analytics workload queues or relying on others to create extracts. Forget data marts, forget cubes. Data analysts can handle multi-billion rows of data with Looker in milliseconds using this combo. One more thing. We've just demonstrated Looker on Indexima on top of S3. In this case, we transformed a cloud data lake into a very fast data engine for instant analytics inside Looker. But you can also have Looker on top of Indexima, on top of any SQL database. I mean, any of your transactional data warehouses like Oracle or many others. In this case, you enable agile big data BI using your legacy system. You could also use Indexima on top of a cloud data warehouse like Snowflake or Google BigQuery. Indexima and Looker helps you to dramatically reduce costs of those wonderful cloud data warehouses. In a nutshell, Indexima and Looker combo is available whatever your data source is, and you can also access your data from hybrid tools keeping Indexima performance and Looker agility. There is no move. You can just dig and use your data, whatever the infra you have.
Thank you so much, Shohei, and thank you very much as well, Nicolas. The whole team remains at your disposal for any further conversation.